Okay, hi everyone. This is Infinity YouTube channel. Please remember to like, subscribe, and share. So today we are going to solve an example on the Fourier series. We are going to see how we can use Fourier series to analyze functions. So the question says find the Fourier series for the function f of x shown below. So as I say, considering one cycle over the interval minus pi less than or equal to x less than or equal to pi. So if you look at this function, this function, you see that the interval that we were asked to find, which is from minus pi to pi, is the entire of this x direction. So you're going to find all the intervals of this x direction. And looking at the y-axis, you see that the height of this interval was 4. So we are going to use that to solve. So since the question says we should use Fourier series to analyze a function, we are going to write the formula for the Fourier series. And Fourier series is given by f of x is equal to a naught over 2 plus the summation of from n equals 1 to infinity an cos nx plus bn sin nx. So this is the Fourier series representation. So as usual, we are going to find the a naught, the an, and the bn. So we know that the a naught is equal to 1 over pi, the integral of minus pi to pi f of x dx. So this, from our Euler's law, this is the value of the a naught. So, but we cannot get just this limit directly from this interval. We have to take the limit, the intervals into consideration, because before we get to this from minus pi to pi, there are other intervals within. So we are going to take into consideration all these intervals. So the entirety of these intervals gives the value of this limit. Okay, so what it means is that this a naught is equal to 1 over pi into, the first one is the first integral. So the first summation the first interval that we have here is from minus pi to minus pi over 2. So we're going to have the integral of minus pi to minus pi over 2. And the value of the f of x in this function, the value of the f of x is the value of our y. So when x ranges from minus pi to pi, what is the value of y here? As you can see, there is no value of y, which means that y is 0 in this direction. So we have 0 dx plus the next interval is from minus pi over 2 to pi over 2. So which is from integral of minus pi over 2 to pi over 2 of f of x as well. What is the value of y when x is within minus pi over 2 to pi over 2, which is 4. So we have 4 dx. And the last is from pi over 2 to pi. So that is from integral of pi over 2 to pi. And the value of y in this direction is 0 because there's no value of y there. So 0 dx. So as you can see, the entirety of all these integrals sums up the limit of this integral, which was from minus pi to pi. So this entire integrals has been represented in this function. So 0, you have to integrate all this function. When the integral of 0 is 0, so this goes out. The integral of 0 is 0, so this goes out. What we have left is 1 over pi into the integral of minus pi over 2 to pi over 2, 4 dx. So, but we have to know that pi is equals to 180 degrees. okay, which means that pi over 2 is equals to 90 degrees. So in your calculator, when you are imputing the values of your pi in a sine function or in a cosine function, anytime you want to impute the values of your pi in a trig function, you are going to make use of pi as either pi or 180 degrees. So, but you have to indicate in your calculator if you are dealing on radian or if you are dealing on degrees. This pi is in radian, while this one is in degrees. So you are going to impute it in your calculator. So let's continue. Now from here, if we should integrate 4, the integral of 4 gives us 1 over pi 4x. Okay, if you integrate 4, you are going to have 4x. So of course, the integral is from the limit of minus pi over 2 to pi over 2. So that's what we have. So these limits are the values of our x. So if these limits are the values of our x, I can therefore say that this is equal to 4 over pi into the upper limit minus the lower limit. The upper limit of this integral is pi over 2, which is pi over 2 as the value of this x, and the lower limit is minus pi over 2, but we are subtracting the upper from the lower, which means we have minus into minus pi over 2. So this is what we have. So this ends up giving us 4 over pi into 2 pi over 2 over 2. So when this cancels out, the values of our a naught is equal to 4. So this is the value of our a naught. Now the next we are going to do is to calculate for our an. So we are going to calculate for our an. So calculating the value of our an, we know that our an is equal to the integral 1 over pi, the integral of minus pi to pi, f of x cosine of nx dx. So using the same approach as our a naught, the only thing we have to add in these points are just cosine of nx. Okay, that's the only difference we are going to add there. So if we just follow the same approach as we did here, we have 1 over pi into the integral of minus pi to minus pi over 2, 0 cosine of nx, plus the integral of minus pi over 2 to pi over 2, 4 cosine of nx dx, and the last plus 0 plus the integral of pi over 2 to pi of 0 cosine of nx dx. So this is what we have. Now this integral 0 cosine of nx gives us 0. This integral 0 of cosine of nx gives us 0. So what we are left with is only equal to 1 over pi into the integral of minus pi over 2 to pi over 2 4 cosine of nx dx. Now one of the rules of integrals is that the constant can come out of the integral. So if the constant comes out of the integral, this integral becomes 4 over pi, the integral of minus pi over 2 to pi over 2 cosine of nx dx. So we are only going to integrate our cosine of nx. Now if you should integrate cosine of nx, you are going to have 4 over pi into the value of cosine of nx dx is going to give us sine of nx divided by n. So this is the value of the integral of cosine of nx. And of course, the limit is from minus pi over 2 to pi over 2. So that's what we have here. So the next thing is that we can remember that the values of these limits are the values of our x. Okay, so I want to bring out this n outside. If I should bring out this n outside, I have that this is equal to 4 over n pi into the sine of nx. Of course, this limit is from minus pi over 2 to pi over 2. So we have to impute our limits into the sine function. So by imputation, we have that this is equal to 4 over n pi into sine of, in this situation, the upper limit enters. So if the upper limit enters, we have pi over 2n minus the lower limit, which is sine of minus pi over 2n. Okay, so this is what we have. So before I just want to impute it here, remember what I said about the odd and the even function. So the odd function is an example of a sine function, and an odd function is a function in which if you have something like minus f of minus x, the output is going to be minus f of x. So we are going to use that same method in this integral, in this function. So if we should do that, we are going to have 4 over n pi into the sine of n pi over 2. Now, since the minus can come out, so if the minus comes out from our knowledge of odd and even function, if the minus comes out, it's going to turn to positive. So positive sine n pi over 2. So this is what we have. Now, if we should add these two functions, this is equal to 4 over n pi of 2 sine n pi over 2. So this is what we have. So the next thing we are going to do here is remember that we have to evaluate this n. We have to know the function, like what this function will be like in each values of n. So that was our aim. Now, what will be the values of this function that we have here when we have n? Okay, and remember that the integrals, that the summation of this n is from 1 to infinity. So let's test for these numbers and see how the sine function can be represented in the Fourier series. So if we should do that, let's test for when n is equals to when n is equals to 1. If n is equals to 1, we have if n is equals to 1, the value of this the values of this function becomes so the values of this function becomes 4 over pi into 2 sine, now n is now 1, so into 2 sine pi over 2. So that's what we have. I will know that sine pi over 2 is equal to 1. So what we have here is equal to 8 over pi. So that's the value that we have, 8 over pi. Now when n is equals to 2, if n is equals to 2, the value of this function becomes 4 over pi into 2 sine. Now n is now 2, which means 2 pi over 2. So, and if you have a function like sine 2 pi over 2, the 2 can cancel out. That means you're looking at only sine pi. And the values of this sine pi is just minus 1. The values of sine pi is minus 1. So minus 1 times 2 will give us minus 2. So what we have here is minus 8 over pi. Now let's check up to the 5th term, then we call it a day on the sign. Now when n is equals to 3, what we have here is 4 over pi into 2 sine 3 pi over 2. 2 sine 3 pi over 2. So when you evaluate that, you are going to have if you check the value of sine 3 pi over 2 and you multiply everything, you are going to have if you should check the value of sine pi, you are going to have 0. So this turns to 0 rather. This is 0 because when 2 cancels out, if you check in your calculator sine pi, you are going to have 0. So 0 multiplies everything, it turns to 0. Now if you have sine 3 pi over 2, if you check it to your calculator, you are going to have sine 3 pi over 2 gives you a minus 1. So minus 1 becomes, multiplying everything, you have minus 8 over pi. Now if you should check for n equals 4, you are going to have 0. If you check for n equals 4, the answer is going to give you 0. Let's check. You have 4 over pi into 2 sine 4 pi divided by 2. Now sine 4 pi divided by 2 can be is same as saying sine 2 pi. And sine 2 pi is 0. So this summation gives us 0. Now if you should check for n equals 5, n equals 5 is going to give us 8 is going to give us 8 over 5 pi. It's going to give us 8 over 5 pi. For n equals 6, if n is equals to 6, you are going to have 0. If n is equals to 7, you are going to have if n is equals to 7, you are going to have minus 8 over 7 pi. So if you should check the series that it's following, it means that when n is equal to 1, 5, 9, and so on, 1, 5, 9, and so on, the values of this function becomes 8 over n pi. Okay, if you have these values of n, you're going to have 8 over n pi. So whenever you have n, you're going to impute these numbers and you get the values straight up. So but when n is equals to even functions, the values of this representation turns to 0. Now, but when n is equal to 3, 7, 11, and so on, the values of this function becomes minus 8 over n pi. So that's how to analyze this function. So the next we are going to do is our bn. The next we are going to solve for is our bn. We know that our bn is equal to 1 over pi, the integral of minus pi to pi f of x sine nx dx. So this is what we have. So just like we did for the cosine and for the a naught, we're just going to impute all these values into there. And we know that if we impute all the values, what we have left is only 4. It's going to be only this function. Okay, but let's do that. So we are going to have 1 over pi into the integral of, the first integral was from minus pi to pi over 2. So minus pi to pi over 2 of 0 sine of nx. Now the next is plus the integral of minus pi over 2 to pi over 2, minus pi over 2 to pi over 2 of 4 sine of nx. And the last is the integral of pi over 2 to pi. So we have 0 sine of nx. So that's what we have. Okay, so we already know that this turns to 0, this turns to 0. So all we have is only this function. So bringing the function out, we have 1 over pi into the integral of minus pi over 2 to pi over 2 4 sine nx dx. So this is what we have. Now, as usual, the constant can come out of the integral. So if the constant comes out of the integral, we have 4 over pi, the integral of minus pi over 2 to pi over 2 sine nx dx. So, and if you should integrate sine of nx, the value you are going to have is 4 over pi into minus cosine of nx all over n. And remember that the integral is from the limit of minus pi over 2 to pi over 2. So we have to impute these limits into the values of x, So I can bring out this n. So if I should factor out n, I have 4 over n pi into minus cosine of nx. This is what I'll have. Of course, it's from the limit of pi over 2 to minus pi over 2. So if I should impute the values of this limit into the values of x, I'm going to have minus 4 over pi. This minus can come out, so that is minus 4 over n pi into cosine of pi over 2n, pi, which is the value of x, so pi over 2n minus the cosine of minus pi over 2n. So this is what we have. So remember that from our odd and even function, one of the example of an even function is a cosine function. So in an even function, if you have f minus x, the value you are going to have is f of x. Okay, so an even function can absorb the negative. So if you should use that approach on this even function, which is a cosine function, so you're going to have minus 4 over n pi into the cosine of n pi over 2. Now the minus will be absorbed, so it's same as saying minus cosine of n pi over 2. So this is what we have. So if this subtracts this, we are going to have 0. So this integral turns to 0. So what we have left is just to represent our integral, our function in the Fourier series form. Okay, so we know that the values of our a naught is 4. Which means by representation, it means that f of x is equal to a naught, which is 4, divided by 2, plus the summation of from n equals 1 to infinity an. Okay, and what's the value of our an? The value of our an is 4 over n pi multiplied by this function. So what we have is an, which is 4 over n pi multiplied by 2 sine n pi over 2, plus what is the value of our bn? The value of our bn is 0, so which means this turns to 0. So this is the only thing that we have in our Fourier series. This is the only thing we have. So let's expand using these limits. By expansion, we have that 4 over 2 is 2, plus, so when I mean expand, it means you're going to impute the values of these numbers into these the values of n from n equals to infinity into these values of n that you have here. But remember, we've already done it. We've done it already. So whenever we have, we know that whenever we have 1, 5, 9 as the values of n, we are going to have the value in this form. So let's go. So when n is equals to 1, if n is equals to 1, we know that if n is equals to 1, we just come here and put n as 1. So what we have here is 8 over pi. So we have 8 over pi. Okay, so but remember that the an was multiplied by the cosine of nx in the summation. So there should be cosine of nx in this summation. Cosine of nx. Thank you. So when n is equals to 1, this is what we have from here. So remember that it's being multiplied by cosine of nx, and cosine of nx in this situation, n is 1. So we have cos x. Next, when n is 2, we know that when n is 2 or any even function, the value is going to be 0. So no need to bother on our even function. So let's go to 3. So when n is 3, we know that it's going to be just to impute n as 3 in this place. So by doing that, we have minus 8 over 3 pi. Now in here, n is 3. So cosine of 3x. So the next is 4. So 4 is going to give us 4 is an even number, so 4 is going to turn to 0. So the next is 5. Now 5 becomes, just impute 5 into this function. We have plus 8 over 5 pi, and it's being multiplied by the cosine. The cosine of 5x. The next is 6. 6 is an even number, so 6 is going to turn to 0. Let's go to 7. 7 is going to give us this type of function. So what we have to do is just to change the number to 7. So we have minus 8 over 7 pi multiplied by the cosine of 7x. So as you can see, this limit goes on and on till infinity. So this is the value of the representation of the Fourier series. So I hope this video was useful and helpful. Please remember to like, subscribe, and share. Thank you.